Hey everyone, I'm Sushant. I work on the post-training org in DeepMind, working on improving coding and tool use capabilities for Gemini. My aim here basically is to explain the lessons so far from building agents. I know agents is an overloaded term, so we'll also spend time defining what an agent actually is, how it differentiates from more simpler concepts such as workflows, and some general advice from a production perspective on how to have more effective agents. Quick overview of the agenda. So basically, I'll try to give some background about post-training in general, because that'll be very useful to understand how that helps in actually building and training useful agents, which can actually work in real life workflows. Like I said, agents is an overloaded term, so we'll also spend some time defining like what agents actually are, or at least give my perspective on it. Very importantly, what's a good use case for using agents, and even more importantly, when we should not use them. Some of the core building blocks of building these agents, and some of the more common patterns we see deployed in production. And we'll conclude with like best practices and give you hopefully a useful decision framework for training and deploying agents in practice. Awesome. So let's get started. Let's start with some background about post-training in general. So the main idea I want to convey here is, why do we need post-training in the first place? So if we start with a raw large language model that has just gone through pre-training, it is actually not that useful for most real-world tasks, or basically because the only thing it is really good at is completing the like next token prediction and completing the sentence based on the context it has so far, which is great, but that is not actually something that we want, something that we have a lot of real like world use for. So that is why where post training comes in, to actually align these pre-trained large language models for tasks that we actually want to use them for. So basically, pre-training is a very expensive process in terms of compute. So you'll end up with this large language model that's really good at next token prediction and has hopefully a good prior of the world in general because of this next token prediction task. And then post-training basically just focuses at making it useful for a wide variety of tasks, such as following instructions, having an idea of what human preferences are given a context, because ideally we want the model to be aligned with what our preferences are as well, be aware of what harmful behaviors are so that it refrains from indulging in those. And then improving, like very importantly, also improving skills in a lot of very important verticals like reasoning, factuality, coding, and tool use. So this is why post-training is extremely useful, and a lot of like care has to go into doing it really well. And that's why it's a very intensive process in terms of both compute and getting really good training data and evaluations. I'll try to quickly summarize without going into the details too much, but basically, generally speaking, it's kind of this three-stage approach where you start with a base model that is also good at following instructions, because so that you can actually teach it other things, but like it needs to have this base capability of being good at instruction following. So you'll do some fine tuning to make it better at that and any other task that you have in mind. You'll also typically collect preference data to train a reward model on, like given a context and given, let's say, two different choices, what would a human have chosen given that context? And you'll train a reward model on this and then you'll use a reward model downstream to fine tune your large language model with reinforcement learning, which we'll also quickly touch in a bit. But this is the process that will, given a pre-trained large language model with some capabilities to follow instructions, you can actually end up with a very useful post-trained model, which is useful at a wide variety of tasks. How kind of frontier post-training looks like, and I've put an asterisk here deliberately because a lot of these like more state-of-the-art techniques are not like widely known, but there are some good practices from good models in the open source space, which will be the source kind of all of our discussion here. So post-training, basically, we want to improve across as many useful capabilities as possible, and then leverage very high quality, like expert human data and also synthetic data. This is what a rough post-training pipeline looks like. So this is from the Tulu family of models from Allen AI. So you basically start with the base model. You use human instructions and like export human data and fine tune it to get a fine tuned model, which is good at let's say following instructions and good at some basic family of tasks. Then you'll collect a preference data set and train a reward model, which will then be used in RL. So the specific algorithm I mentioned here is PPO, but it could be other things as well. And you'll use reinforcement learning to then come up with a final aligned model. This is another example of like a post-training pipeline for Llama model from Meta and Emotron from NVIDIA. Fairly similar, it's just that you use some other techniques. You can use DPO as well in your reinforcement learning step of the pipeline. This is another pipeline from the very useful post-training report from Llama 3, which I highly recommend reading. I won't go into the details too much, but basically it has a fairly similar structure from the last two diagrams we saw, where you kind of start with your best model checkpoint you have so far. You collect a bunch of really good prompts and completions to iteratively improve it further by fine-tuning. And then you also do another round of RL, in this case, let's say using DPO to come up with a better aligned model, and you can keep doing this iteratively to come up with better and better models. Quickly now touching upon reinforcement learning or RL as well, because this is also a critical part of how we'll actually end up training agents. So typically in reinforcement learning, the most important concepts are that you have an agent, which in this case will be a large language model, which has the capability of interacting with this environment. So it's at any given state ST, it can take any action AT. And based on the action, the environment will give it a reward RT, and the aim of the agent is basically to maximize its expected reward and take the actions which help it maximize its reward. How this fits in a large language model setting is that your agent is basically, like I said, a large language model policy which you're trying to improve. The action is basically the token it predicts to complete the prompt. And your target environment, that is very interesting. It could vary. It could, for instance, be a reward model, which gives it a reward. It could be something else. It could be some predefined reward, but you basically give it a reward based on how good the completion is. And that reward will be used to improve the policy so that it can come up with better and better completions next time. How this actually works in practice. So this is basically the RL pipeline I had alluded to in the post-training pipelines we saw. But basically, you'll have your training data and your large language model policy. We call it the agent. Will do a bunch of completions. Your reward model will give it a reward for each completion. So let's say you have a prompt. Your large language model comes up with the response. You'll assign a scalar reward. So let's say the response is really good by some metric. Let's say you give it a score of 10. If it's not good, let's say you give it a score of 0 or 1. And based on this reward, you're using a standard RL algorithm like PPO or DPO. Feel free to look those up. There's fairly standard now in RLHF pipeline these days. But based on those, using some algorithm like that, your agent will basically update its weights so that in the future it has a higher likelihood of coming up with completions which will give it a higher reward. Another very useful thing I want to quickly point out here, which is especially useful in the context of agents, is RL with verifiable rewards. So how this differs is, for a lot of like actual real life workflows and complex tasks, it's easier to actually just have a ground truth reward, like a binary ground truth reward. So for instance, let's just say we're talking about some complex task like which we'll come into some examples later as well, but where you know kind of what the final answer, like if the agent ended up doing that, it's the correct thing to do, so it should get a reward of 1 versus otherwise it should get a reward of 0. So this is a very useful way to set up your RL environment, because you don't really care that much about what intermediate steps, at least for some use cases, your agent takes, but you really care about if it actually ended up doing the right thing or not. So this is a good scalable way of setting up your RL pipeline, where you just need to come up with the prompt and you know what the final answer is. And you can set up your pipeline in such a way that the agent will, if the training is done correctly, the agent will end up coming up with actions that gives it higher probability of doing the final action, which gives it a positive reward. Awesome. Okay, so I think we covered a fair bit of background that will now help us understand agents and what are the best practices for deploying them. So firstly, like just very quickly, actually what are LLM agents, because agents have become a fairly overloaded term. So I want to make sure we kind of have a good understanding before going further. So you can think of agents like in the simplest possible way as a large language model, which has some agency over tools and actions. So it has the capability of deciding which tool call to make or which action to use given on the context it has so far. Um, and more importantly, like these actions or like these choices can be dynamic based on the current context. So there's an important distinction to make between workflows and agents. I feel a lot of the times when people use the word agents, they're actually could have just used the word workflow, or like what they're actually referring to as a workflow, which is sort of more predefined. It's more deterministic. Like there's a fixed uh, sequence of steps you have to follow no matter what. Versus, I feel where agents fit better are where it's the actions the agents can take are more dynamic, more contextual, and the model actually has the agency to choose what to do versus having a predefined set of action that it has to take no matter what. So you're basically like letting the agent do this kind of dynamic planning, and then having this ability to do, like, for instance, sequential tool use for complex tasks which have multiple steps. Uh, so I think this is a very important, like when to use, based on the distinction we just saw, when to actually use agents. The best use cases where it's kind of worthwhile to justify the engineering complexity of using agents is when your problem is more open-ended. It's unpredictable in the sense that there is no predetermined sequence of steps that you have to follow, and you do not know in advance how many steps there will be for some given prompt. And the task kind of requires the agent to dynamically adapt based on the intermediate result. So let's say based on result in step 3, like step 4 would look different. Like there could be 5 different possible steps for based on what the response from step 3 looks like. Your model should also actually be capable enough to be able to do planning reasonably well. If you do not have a, like after, let's say, the post-training pipeline that we just went over, if you actually do not have a good model that is capable enough of making these calls, like of making these decisions in a reasonably intelligent way, you'll actually not end up with a useful agent, because your model will actually make suboptimal decisions, which will make it actually, those errors will kind of compound. And for instance, complex problems where you need like 10 steps to get to the right answer, it will be very unlikely that the agent ever ends up reaching the final step correctly. Also very important, like I said, to have clear success criteria and feedback loops, because that will actually make it easier for you to improve your agent. If you actually have a feedback loop where you clearly know if the agent succeeded or not, you can actually use that data and feed it back into the RL with verifiable rewards pipeline that we just saw to improve your agent on the task. That so you start with some baseline success percent, like success percentage, or at your current agent's performance is, let's say, 20%. But you can use these feedback loops and collect this data to hill climb and improve your agent to, let's say, get to 90% plus, which is, or 95% plus, because you need fairly high success rates to be able to like reliably deploy agents in practice. You typically do not want an agent which has a success rate of 50%, 70%, even 80% for important use cases. Equally importantly, if not more importantly, it's also good to know when to not use agents. Like again, if you think a simple, like if you can just do fairly sophisticated, let's say, prompt engineering, and that is enough. Like you can tell the model, here are like 3 or 4 things you can try. This is what you should do. You should actually just stop there, and you do not need to go to more sophisticated or like over-engineered setups if that suffices. Because one thing to call out also is like state-of-the-art models are becoming extremely good. So a lot of the cases, good prompt engineering is actually enough. So you should definitely try that first. Likewise, when your task is more fixed or unpredictable, you actually do not need this. You probably just like a simple workflow, or like you can simply tell you, like in a prompt, you can specify these are the 5 steps you always need to follow no matter what, and that should typically be enough. It's also important to have this, keep this in mind, that latency and cost for agents are typically higher because you have multiple steps. The number of steps are dynamic. So if a complex task can actually end up costing significantly more because it can require more steps, and these LLM calls are fairly expensive. So make sure you always have this trade-off in mind as well. Also, quick distinction between when should you use an API or framework. So like there are a lot of existing frameworks like LangGraph, Elm, which make it easier for you to get started. But an important thing to keep in mind is this ease of abstraction can actually hide what underlying prompts they're using and make it very hard for you to debug if something goes wrong. Was there something in the model quality? Was there something wrong in the prompts that the agent is using behind the scenes? So if you're using a framework, make sure you really know what's going on. Otherwise, it's easiest to just kind of start with these enterprise LLM APIs or any of these APIs from these state-of-the-art model providers. Just so you know basically what's happening and you are kind of in control if things go wrong, and you can make it easier for you to debug things. Okay, let's quickly start with like the first building block of, let's say you've decided your workflow, or like basically your problem is deserving of an agentic setup. What would you start with? So the easiest building block is just kind of this augmented large language model setup, where basically it's just some capable LLM and you provide it with the ability to use tools and do retrieval. So this becomes the foundation for like more complex patterns that we'll get into, but this is the simplest sort of setup which can work for like the more simpler tasks. Basically, you give it sort of the relevant context, and it has the ability to use tools such as, let's say, web search or calling some other APIs. This actually can suffice for a lot of simpler use cases. Again, make sure your model is extremely familiar with how to use those tools. So you should give these very well-defined schemas and APIs to the model. So have them in the prompt, or give it few short examples that go over how to call the API correctly. So when you start with the setup, now we'll get into like more complex setups for like more nuanced workflows. So one sequence, again on the sort of easier side, and we'll go into like more complex setups, is this set of like sequential prompts. So again, this is sort of still relevant for a little bit more predictable steps. But basically, what you can do is have this set of like sequential prompts, and after each stage, you make sure you have a really strong like validation check to make sure your previous stage was completed correctly before you go on to the next step. The checks here can depend again on the complexity of your task, but this is kind of the more easier setups to kind of have, where it's still fairly certain what kind of your steps might look like, but that still gives you some agency, because before proceeding to the next step, you kind of have the sophisticated checking mechanism, which know if you've done the correct thing so far, and only then you kind of proceed to the next step. So this can suffice for sort of more simpler use cases. Like a simple example of this is like a lot of these generative AI use cases we see is like filling out documents, filling out forms. So what you do is, for document creation, for instance, you generate like an outline, given a prompt of what document you want to create. The agent kind of generates this outline, or comes up with like relevant sections. Validation criteria could actually look like, do I have actually covered all the relevant sections? Have I missed anything? And once you fix that, then you can kind of go into each section, and the agent can start filling out those relevant sections and have another final review before completing this. So, but this is like one example of what a simpler setup could look like, which is still roughly fitting into this agentic setup, but still has a lot of overlap with the workflow definition I discussed before. Now, actually going into more useful and more sophisticated setups, another very common one is model routing. So basically, you have an initial router, which is also basically it could be a simpler model, but typically should also be a large language model, because the quality of this router will actually determine the quality of how your task ends up planning out. So I want to make sure this model is also really good, because otherwise this could be a bottleneck. So your initial model classifies the request and decides which specialist model to route it to. And that specialist model could have its own different context, different prompt, different system instructions for that specific task. So how this helps is, you do not need to have one huge model that is supposed to be really good at everything. You could actually make do with smaller but much more specialized models, which have been fine-tuned for that specific task. And your router then just routes your prompt to the relevant model and gets a response. So this setup actually works surprisingly well for a lot of use cases. One thing you have to be really careful about is how good is your like triggering or routing actually. So how is your router actually routing tasks correctly? This is something you have to constantly keep monitoring. There's no easy way around like doing this once, because you do not know what the distribution of real world queries could look like. So it's always worth it in these cases to spend enough time in looking at your logs, seeing what your routing is looking like, and then always updating it and correcting it as necessary. So you should basically keep making sure that your router is as good as possible based on the usage you've seen so far. Several examples of this, which are very commonly deployed these days. For instance, you could think of this is actually something also a lot of frontier model providers are doing. For instance, based on the complexity of your query, they can decide behind the scenes which model to call, because if a prompt is simple enough, it does not make sense for them to kind of route it to a very expensive larger model. If there's a more specialized smaller model or lightweight model that can help solve it. You could also think of it as there's some enterprise use cases where you have a sophisticated router which kind of decides the intent of your query and then routes it to a smaller specialized model. And that setup is still overall way more cost effective than having one huge model, which is supposed to be state of the art on everything, versus having smaller models which can be extremely, extremely good at very specific tasks. Another pattern that is really common, and I'll also give examples of how it's also common in a lot of these coding agent use cases, is having this loop of evaluators and optimizers. So basically your generator, what it does is your generator part of so you can think of as so these could be same LLMs as well, or different prompts, or these could be two different LLMs. But think of a generator which produces a draft, and then an evaluator goes over or critiques the draft and sends it feedback to the generator, which then improves the draft. And this keeps on going till your success criteria is actually met, or you reach some max number of iterations beyond which you have to stop because of some infra or cost constraints. One very important thing to make sure is you actually know, and it's deterministically what your success criteria is, so you know where to stop there. But a great example of this is a lot of coding agents can have the setup where you have a coding agent which writes code, which runs in a sandbox, and then you kind of have this evaluator agent, which could basically be the same underlying LLM with a different set of instructions, which goes over the results and see if the code actually ran, was output successful, did the plan that the coding agent came up with make sense, and if not, it'll basically send its critique. Or basically, let's say the code did not run, the evaluator agent will kind of see what the failure was and come up with a new plan and send it back to the coding agent. So this is also a pattern which is really useful in practice. Yeah, these are some components of the workflow I just described for this. But make sure, for instance, there are ways to get realistic feedback. So for instance, for code, it's easier for code because you can just run your code in a sandbox and see if it compiles, see if it runs, what the output looks like. Also make sure there are guardrails in place to not kind of keep doing this indefinitely. You need to have robust stopping conditions. So basically these calls are expensive. So make sure you have well-defined stopping criteria of, okay, you've reached 10 steps, you don't want to keep going, and it'll make for a poor user experience. So make sure you have well-defined stopping criteria in mind. You could have some intervention points for human in the loop. For instance, let's say if you find that your evaluator find that you actually need some clarification. You'll see this in a lot of deep research models, that if they actually have some follow-up questions, they'll actually ask you that before going further. So it's useful to have those also. And some baked-in error recovery that your model may hopefully seen it in post some part of your post-training pipeline of, given some error, what's a graceful way of recovering from that particular error. I'll quickly go over some agents, some examples which work well in practice because they're very, very similar to and well suited to the sort of patterns we just saw. For instance, customer support agents is something which is becoming really popular and works really well for a lot of cases because it's fits in well with the patterns we discussed. For instance, you have very clear success metrics of whether the user was satisfied with the resolution or not. So you kind of have this easy way to close the feedback loop and collect data to make your agent better and better as you keep getting more training data. There's also it's also well suited in the sense because you kind of have this, you can have this usage-based pricing where based on how successful your agent is, you can keep your pricing that way. So it's also one reason kind of these agents are becoming so popular, because, and it's also I think one mode which is becoming fairly common with enterprise agents in practice is having this usage-based pricing on success rates based on the success metrics of the agent. Another extremely popular example, which I think all of us are are well aware of is coding agents. So all frontier providers have extremely good coding agents at this point. And this is a problem which lends itself very well to this agentic setup, again, because of firstly feedback loops. Like if you have a comprehensive test suite, and given, let's say you have a pull request that you want your agent to work with, it's fairly easy if you have a good test suite to figure out like if your agent actually did the required job or not, and you can collect like really useful training data that way. And this is also something that LLMs have seen a lot in their pre-training. This is something that they're actually already good at. And if you close kind of this feedback loop for your agentic setup, you can actually train like really useful agents, which is why models now are like really good at doing extremely complicated coding tasks. Uh, I'll start by like concluding over like some of the frameworks and the decision framework we just went over, or like to help you kind of decide whether you kind of need, if you firstly need agents in the first place, and if you do, what kind of framework you should choose, or like which pattern you should choose. So like firstly, you start with a simple prompt, which has kind of all the details, has some few short examples of what you want your model to do, and see if that suffices. Like a lot of the cases, a lot of simple use cases, especially with the soda models that we have now, that actually might be enough. If not, then you should try to think about like more of these sequential prompts where it's still fairly deterministic, but your agent kind of has agency over what's the right tool to use at which point. So that's kind of the next step in your workflow if you find that you're not able to complete your task with just prompt engineering. This is kind of similar to the deterministic workflow chain setup, and then kind of have an agentic loop where it's still dynamic. Like your agent can actually decide what tool to use at which point, and the number of steps are not defined, but you still have some guardrails around what the agent can do or not, and you kind of have, let's say, some hard stops on you want to stop beyond this point. And the final mode is like obviously for more autonomy, where the agent gets to decide the stopping criteria as well. But again, that there are only few use cases that might fit well to that, and it also has trade-offs in the sense of it can be extremely expensive as well, because any like basically calls to these, especially the frontier models, are fairly expensive. But yeah, I think the kind of 3 points I like to go over when kind of deciding, or like principles to help decide your design pattern for agents, are basically try to prefer like simplicity over complexity. For a lot of use cases, you do not actually need to do over engineer things. Like these models are really kind of getting better and better at helping understand your intent. So a lot of the times just giving it the right context and a fairly detailed prompt is enough. Like make sure you have like really good controls over seeing the traces, or like the reasoning traces and thoughts, and debugging the final output. So if something goes wrong, like you kind of have a good understanding of what the problem is. For instance, whether something suboptimal in your prompt, were the future examples you gave not sufficient, or did the agent fail in a new kind of an example? So just make sure you have transparency over what your agent is doing. And again, I think a very good sort of principle that does not get highlighted often is make sure you have a really good, like we call it like an agent computer interface, like ACI. Like try to think from the agent's perspective. Like for instance, if you're giving it a task, let's say it's a computer use task, like just try to think of what the agent is seeing. The agent is likely seeing like a screenshot of your screen, some icons. So just try to like engineer prompts and engineer setup from the agent's perspective. See kind of what context it has access to, what are the tools it can use, what do those APIs and those schemas look like. That will kind of help you basically have a lot more context for what context like you should give to the agent, and what like should go into your prompt, what should go into your future examples. For instance, if the task is complex, is the context length of the agent that you're using, is that long enough for it to be able to do complex tasks? So just think about all of these cases. And the best way to do is kind of like try to think from the agent's perspective. Again, important to have like guardrails and good evals in mind. So start with some solid like baseline, but then like as you keep iterating, make sure you keep measuring performance. And like if you're trying to improve on something, make sure you're not regressing on other things. That's something that kind of happens also more often than I would like. So make sure you have very comprehensive evals, and if you're improving on something, make sure either you're neutral across everything else, or hopefully improving across other verticals or other dimensions also. And test obviously in like sort of sandbox environment before you roll something out in production. Like this sounds obvious in hindsight, but a lot of times what I find is we could have done, like, basically it's always beneficial to do sort of more testing in sandbox environments before, especially rolling out more autonomous agents, which we do not always know. Like, if they kind of start using some tools in unexpected cases, it's always better to kind of err on the side of caution. And we went over some of the don'ts, like don't over-engineer unnecessarily, don't hide behind abstraction where you don't know what's going under the hood, like what prompt is being used. Just make sure have a lot of transparency into what your agent is doing. And when necessary, it's always beneficial to have some human in the loop and have a human oversight to keep understanding the nuances of how your agent can keep improving. Yeah, I think it's very similar to what I went over earlier. Like, just be prioritize simplicity, transparency, and then craft your ACI. Try to engineer your context and environment from the agent's perspective. I want to also leave a couple of minutes for questions if you have any.
So the first one was, what are the best practices for fine-tuning agent code base in production?
Sorry, what was the last part? For fine-tuning agent?
Agent code base in production.
I see. Do you mean does the question mean fine-tuning agent, like coding agents? Or actually, let me try to answer like my best understanding of it. So I think fine-tuning agents in production, what I would recommend is, like, first, like I said, close the feedback loop in terms of collecting data points specifically for where your agent is failing in these production use cases. Make sure you know for what use cases your agent is not doing the recommended action or set of actions, and then have these like very frequent like feedback loops and iteration cycles. Like, for instance, Cursor, I think, is doing something really remarkable where it kind of has these iteration cycles of a few hours where it collects like data points from like its agents which are actually being used in production, and then uses this to quickly have like ship the next version of the agent after doing RL on the data it just collected like a few hours prior. So that's an extreme example of, I think, that requires very sophisticated engineering and infra, but maybe even like some example of that where you kind of do that iteration every few days or like in a week or so will be very helpful.
Awesome. Another question here. Regarding your point on simple composable patterns instead of heavy abstractions, could you elaborate on what makes today's agent frameworks such as LangGraph feel overly complex? Also, which architectural principles from your DeepMind experience do you believe teams should prioritize when designing?
Yeah, that's a good question. So in terms of the first one, I would just say these abstractions actually make it easier for you to get started. But what I would recommend is seeing sort of under the hood if there's any, like, is the model or the agent seeing anything else beside the prompt that you just specified, and is your prompt, for instance, being augmented in any way by any of these abstractions? Is there sort of any other context that the model is seeing which ends up altering your prompt in any way? Like, if you're just using a simple API, you can be really confident that the model is just seeing what you send it. So I would just recommend, if you're using any of these frameworks also, they actually make it easier for you to get started also, but make sure you kind of understand if there's anything else going behind the hood which could be different from the intent you had in mind. And also you have complete transparency of, for instance, seeing the model's output and its thoughts and action. In terms of principles, I think I would basically recommend the few things we already discussed, which is start with like strong but simple baselines, and then only engineer more if you need it. One pattern I've been seeing across the industry is, like I said, you actually do not need very complex setups for a lot of tasks. And that is really different from, let's say, what I saw in the industry over last year. So models now like getting substantially better at even just taking simpler prompts and maybe a few examples of how you want the models to operate, and like really doing remarkably good jobs of generalizing just from this limited context. So I would recommend starting there, establishing a good baseline. And if you feel you have also one very important point is have very comprehensive and good evaluation sets, and then very empirically measure where you're failing, and then try to hill climb on those aspects.
Awesome. And if anyone else wants to submit a question, here we have the 9-dot meeting tools there in the bottom right. Otherwise, I'll close out with maybe a more philosophical one. So we have agents fulfilling finite roles or preset roles such as customer support and coding. Do you think as agents emerge in different roles that in itself will exponentiate more opportunities for agentic AI?
So do you mean as we roll out more agents, will that create opportunity to have more agents in practice? Is that, am I understanding that correctly?
Yes. Will it create new use cases that might not currently exist?
Oh, that's a great point. I think that's a great question. Uh, I feel, yeah, it's this paradoxical situation where I kind of am in this school of thought, like if you have more agents, if you're able to create more software, that will actually have these nice downstream effects of actually being like opening up more opportunities to create useful software. Like I feel like currently, like software engineers, research engineers, I feel we are bottlenecked by how many good engineers there are. But as the cost of like creating good software goes down rapidly, well, with these agents, I feel we'll see an explosion in the in the demand that we can actually like new demand for this, since this becomes so much more cheaper. So I'm actually in that school of thought. I'm really looking forward to how agents kind of create these more interesting opportunities down the line.